is this? These are ferrofluids. I assume you're probably like, what are ferrofluids? Let me show you. When you see ferrofluids, you might just think it's just a normal liquid that's magnetic. There's nothing really interesting about it. But whenever you get up close, you see that there's spikes. And it just keeps growing. Then it's liquid again. It's really magical stuff, it is. So, what ferrofluids remind me of is the Big Hero 6 movie, where it's like the evil magnet, gooey stuff, and it's black, and it's kind of like powered by the villain. That's what it reminds me of. Ba-la-la-la. So, you're probably like, how does this work? So, the ferrofluids are made up of a bunch of nanoscale particles. You're probably wondering what nanoscale particles are. Well, nanoscale is a different solids that are 1 to 100 nanometers. And they're usually magnetic, the solids. And then particles are super small things, which you can't see, only in a microscope, that make up matter. So put them together and it's a super duper small particles that are magnets and 1/1000th of a meter. So, bam, that's what the iron ingots in this are. It's some form of nanoscale thing. So, with a magnet, there is a south pole and a north pole. I don't know which one is which. But I'll put an image up here. There's usually, if you have one of those magnet sticks, there's usually a north pole and a south pole. And in the north pole, so this, let's act like this is the north pole and this is the north pole. It tries to make it not. And I just want to pay extra close attention to what the ferrofluids do whenever this side of the magnet comes close. But then there's a north and a south pole, and they attract. They actually make the spikes bigger. So that's basic magnet knowledge, and I actually have a exciting experiment to do. So let's get into that. So for the experiment, I'm going to be testing if different magnets other than this really strong one attract the ferrofluids. So I have a metal spoon, definitely a magnet. I have a scissors, which also definitely a magnet. I have a kind of like a stronger magnet. It's has a full thing and it's heavier. It's definitely a magnet. And then I have a lighter weight plastic magnet that has that in the middle. And it's so see, these two poles are the south pole. So, anywho, magnet. So, this obviously attracts it, and this one kind of like makes it push away, but it still attracts it. So these, even if it's the north or the south pole that's facing it, it's still going to stick because it's iron ingots. So we're going to first start with the plastic lightweight magnet. So we have ferrofluids right here, and it works. So we're first going to test this side. So this side is they're the same sides here. I'm trying to kind of pushes its way away, because this side isn't really like that powerful because it doesn't really have a magnet showing. While this side, it works. Ah. Wow, so I'm going to put this over here with the work. So now I'm going to switch to the scissors. They actually have cute little ice cream designs on them. I really like these. So, as we saw, magnet. So we have the Ferrofluid, so I'm going to let them. Oh, that's awesome. So it's not as good as this one. Wow. Still pretty good. Still works. Not as good though. So I'm going to put that in the kind of pile. So now we are going to test the spoon, which is a magnet. So spoon, we're going to go from the top like that. Hello. So it really doesn't work. Interesting. So the metal's in this spoon, even though it's super strongly magnetic, it still doesn't. Like, I mean, it just scares them Ferrofluids. They're kind of like, hey, stop. So now, lastly but not least, I'm going to be trying this magnet, which, as we just saw, it's a magnet. So we're gonna, it works. Okay. It does kind of like, this side kind of like, oh, do you see that kind of reflex? How it's kind of like, so normal. Ah, it shakes. It's like COVID. Stop. So then you drop it on top like that. So that's my experiment. Now we are going to explain how this happens. So, as we know, Ferrofluids are made up of oil and a nanoscale particle or solid. So it's made up of like basically oil magnets. So whenever it pulls like this, it's kind of trying to escape, if you know what I mean. So the nanoscale particles they're trapped in a bubble, so they don't mix. So whenever like a magnet comes, they're not mixing together and becoming a gooey ooey liquid. It becomes like pointy and spiky because it's trying to escape to like gravity. So in conclusion, we learned that nanoscale particles are super duper small. The nanoscale particles are also trying to escape at the same time. Ferrofluids are made out of 2 ingredients. They work like they do because the magnets are attracting, and most importantly, Ferrofluids are pretty awesome. See you next time. Bye.